Welcome back! So far in this course, you have deployed a WAR file to a live EC2 instance on the internet. But, of course, it was working with local data. We're now going to progress our system so that we're working with a live, running MySQL database live on the internet. And, of course, you could do that by using your EC2 instance and installing MySQL onto that instance manually, and then configuring the database in the usual way. There's absolutely nothing wrong with doing that. It's perfectly viable. But as part of the Amazon Web Services, there is a further service called the RDS, which is, as described here, a managed relational database service. Now, what you're really doing, if we just follow the link through to RDS, what's really happening here is you're going to be getting another EC2 instance, but an instance that is pre-configured with the database already operating. So it saves you a lot of time in that you don't need to do much setting up, and I'm hoping that this chapter isn't going to take very long at all for that reason. But you also get huge benefits, such as, for example, your backups are automatically set up, configured, and managed without really much work needing to be done. You can do all of this using a standard EC2 instance, but the Amazon RDS takes away a lot of the pain. So there's really not a lot more to say than that. I think we're just going to dive in and create our first database. So I guess we can click the Get Started now, but I'm a bit worried this looks like a bit of a sales pitch, so you may or may not see this page. But we can go to the Instances link here, which is giving us a list of all of the databases that we currently have running. Now, I would make sure that you're in the same region that you were in when you did your EC2 work in the previous chapter, which I assume you will be, but it's worth checking. And the note here is reminding us that the DB instances will launch in, and I'm in the Ireland region. So it's pretty much a wizard that we need to follow. We're going to launch a DB instance, and the RDS service supports a collection of different database engines. You can see that there's, at the time of recording, they may well have added more by the time you watch this, but there's Microsoft SQL Server, there's Oracle, there's Postgres, there's MySQL, MariaDB, and there's also Amazon Aurora, which is kind of intended to be a direct replacement for MySQL, but with higher levels of performance. Now, feel free to investigate any of these. I haven't any experience of using Amazon Aurora, although it looks very interesting, but I'm going to go for the safest option, which is MySQL. So I've clicked that option and we'll select that. Now the next question, and this is an important one for the course, do we plan to use this for production purposes? What they're offering here is a feature called multi-AZ or multi-AZ deployment. Now the AZ or AZ stands for availability zones. We haven't talked about that yet in the course at all. At some point, we will be going into great detail about availability zones. An availability zone is where each region is divided into separate locations. You can think of the availability zone as being a different data center at that location. So the idea behind this multi-availability zone deployment is you're effectively going to get two databases, a master and a slave, in different data centers. They'll be in the same region, but different data centers. So of course, the idea is if your master database goes down, then your slave instance will be able to take over. So this is obviously very useful in production deployments, but we cannot do that on the free tier. So for this course, you definitely want to be choosing no. Otherwise, you're going to be hit with charges. So once you've selected no, we'll go to the next step. On the next page, we can specify the specific version of MySQL that we want to use, and the default will be the current latest version supported by RDS. The instance class is very important. This is exactly the same decision you need to make as when you were working with EC2. There's a huge collection of different instance types. For this course, we want the free tier, so we'll be using T2 or whichever number you see there, whichever's the first in the list really, the micro version from the T series. Now, before I go any further, I'll talk about what we get for free in RDS, and it's basically the same as EC2. You get 720 hours of free RDS use per month. And again, if you do the mathematics, that means as long as you only have one of these T2 micros running for your database, then you will get that completely free for a year. Now, notice that your kind of allocation for RDS is separate to your EC2 allocation. So it's absolutely fine to have, as we have on this course, we have an EC2 instance for our web server, and we're going to have a separate EC2 instance for the database server. But that's fine because we have a separate allocation for RDS. For multi-AZ deployment or AZ deployment, we've already said on the previous page, but we've got to say again, no. Storage type is SSD. We'll go with the default of 5 gigabytes. We need to give the database an identifier. In fact, this identifier is going to be really just used for Amazon purposes. We won't be seeing this identifier in the code. Most importantly, it is not a schema name. So this is an Amazon identifier. I'm going to go with bookstore-database. We need a username and password for this database. I'm going to go for VPP admin and the same password. Again, as on the previous chapter, I'm doing that to make the recording easy so I don't forget what I've done, but you should be using a strong username and a strong password at this stage. Remember, this database is going to be live on the internet. So whatever you use there, be very careful to note them down, and you will need it for the code. So we'll go to the next step. And now we're on the final page, and we can accept most of these defaults. But one interesting one is the field here, which is asking if we want the database to be publicly accessible. Now, if we select yes, then this database is going to be accessible outside of our virtual private cloud. And that really means, at the moment, that means the computers that we've defined on Amazon Web Services. So by selecting yes, this database will have a public IP address. And that means we can connect to it, for example, from our desktop computer. If we were to say no, then there will be no IP address for this database, and the only way we could connect to it would be from our Amazon hardware, for example, the EC2 instance that we have running. Now, this is an important decision to make when you're deploying. I would suggest that the safest option is to go for no. That's going to make your database a lot more secure. However, for the purposes of this course, I would like, for experimentation purposes at least, to possibly connect to this database directly. So we're going to go for a yes here. And we're also going to be creating a new security group for this database. You know now that that means a set of firewall rules. We are going to want some firewall rules for this group. We will want to be allowing access to port 3306. For the database options here, the database name is the default schema. Now, if you can leave this blank, and in which case it won't create a particular schema, but we don't have any data on this database and we're not doing an import or anything like that. So I would like a default schema to be created. I'm going to call it bookstore. Again, if you use a different schema name here, be sure to make a good note of what you've used there. Going a little further down, we can configure backups. The default retention period for the backups is 7 days. And the backup window just means when is it going to do the backups. And you can configure a backup window. Also notice by default, it will automatically do upgrades of the database for minor versions, but not for major versions. And again, you can set a window for when it does that upgrading. I'll leave that on the defaults. That's all there is to it. We can now launch the instance. So we have a message saying it's been created. It will take a few moments to launch, but we can already go to the View Your Instances, and it's a very similar window to the EC2 window. We have a list of all of our instances here and its current status. So now you just need to wait for the status to change from creating. So that took quite a while to start up, and you may have noticed that before your status became available, the RDS system did a backup. But eventually you should see your status as available. Now, obviously the objective of this is to connect our web application to that database, but I think just for a test, just to build some confidence really, I'm going to attempt to connect to this database directly through a command line. There's lots of ways of doing that, but I think probably the easiest is to use our EC2 instance and run a MySQL client from there. Now, at the end of the last chapter, I closed down my EC2 instance, and you might have done the same. So in which case, we will of course need to go back into EC2, check your region's correct, and click the link to running instances. Well, I have no running instances at the moment, and I will need to select my test server, select Actions, Instance State, and Start. And then after confirming, as usual, it will take a short while for this instance to be available. Notice while that's starting that the current public IP address is not set. Now you're going to find that the IP address that you had last time is almost certainly going to be lost. You will get a brand new public IP address once this server has started up. So you need to be aware of that. Now don't worry about that. We have a very easy way of getting ourselves a kind of permanent IP address, and we will look at that in the next chapter. But for now, you will need to make a note of your new public IP address, which I'm now seeing here. So my instance has now completed its status checks. So back in the Cygwin client, again, we're going to need to change directories into the same directory that you downloaded the PEM file. So just to remind you, we will use the mount point of /sig drive, followed by the usual path, but case sensitive to wherever you have stored your .pem file. For me, that's the downloads directory. Then it will be ssh-i, and it's myKeyPair.pem for me. The standard user is ec2-user, and then @ and you're looking for your public IP address, which for me is 54.229.0.107. You might be asked at that point for a confirmation saying the authenticity of the server can't be verified. You just need to say yes to that prompt. So the only reason I've gone on to the EC2 server is because I don't know if you have a MySQL client available on your desktop computer. If you haven't, then it would be a boring process of downloading and installing and all the rest of it. But on our EC2 instance, we can really easily install a MySQL client with sudo yum install MySQL. And this is going to install just the client application for MySQL. Confirm with a yes, and that took no time at all. So now if I type MySQL, that's great. We are getting an error. It's saying we can't connect to the local MySQL server, but that's because there isn't a local MySQL server. So instead, we can do MySQL, and we're going to use -h, which is the option to supply a remote host. And then we can supply the IP address or domain name of our database server. Well, we'll need to find that out. So we do that by switching back to the front page and then onto RDS. Click on Instances. Select your database instance, and you should be told here the endpoint of the database. And we can use that as the host name of the database. And I can click on that and copy it. By the way, in Cygwin, to paste, you'll either right-click and select paste, or the shortcut key is Shift and Insert rather than Control V. The reason for that, by the way, is simply because if they supported Control-C for copying, well, on terminals, that represents a kill command. So that's why there's these strange hotkeys. So Shift and Insert there. Notice they've put the port number on :3306. Actually, that's the default port, so you don't need to have that there. We are going to need the username and password. So I use the user -u. You just follow on with the username, which is vppadmin if you use the same as me. And then -p, again, no space, but then your password. Now, I used vppadmin. I did advise you to use a better password there, so I hope you made a note of it. So let's see what happens. I did an edit there because that command froze for quite a long time, and it should have done the same for you as well. So it feels like a firewall problem that we can't get a network connection to that server. And that's absolutely true. If you go back to your RDS dashboard on your instance list and select your database instance. Now, I have a strange feeling that this user interface might change over time, so it might be slightly different for you, but somewhere in here, there is going to be a link to show you the security rules for this database server. At the time of recording, if you hover over this info button here, it's giving you connection information and it's showing you the security group rules. Now, I glossed over this a little bit when we started up the database, but it created automatically a new security group for you, which was called RDS Launch Wizard. As you know now, a security group is a set of firewall rules. And we can click through to that set of firewall rules. And actually what it's just done is it's taken us back to the EC2 dashboard, but it's showing you the setup for this particular set of firewall rules. If you click on the Inbound tab here, you should find that the only rule that it's created so far is it's going to allow traffic TCP on port 3306, which is what we want. But you'll find that the IP address here, you might not recognize it, but it's actually your own IP address. So that means you can access the database through your own desktop computer, but not through any other computer. Now, of course, we could have installed a client onto your desktop computer, but I just didn't really fancy going through the pain of that. What we want is the EC2 computer here, which remember is a different server. We want this to have access to the database server. Now, in future modules of this course, we will go into a lot of detail on networking in AWS. In particular, we'll be looking at virtual private clouds, or VPCs. And to configure a VPC would be a really good way to give these two computers visibility of each other. But for this module, I just want to get up and running quickly. I want to establish the principles. So all we're going to do is we're going to add another firewall rule to allow this computer's IP address to see our database server. So we'll be doing that by editing the inbound rules. Make sure you are on the inbound rules and make sure you don't do the mistake I did earlier, which is don't edit this existing one, but click on Add Rule. This is going to be a custom TCP rule, TCP, and the port range will be 3306. And for the custom IP, of course, you could type in the IP address, the public IP address of the EC2 instance, but there is an easier way. If you just start typing in here, and I just hit a space there, we have here a list of all of our security groups. And if you select the security group for the EC2 instance, then that will give the EC2 instance visibility. Now, I have been a little bit slapdash on this course. I haven't given good names to these security groups, so it might not be obvious, but it's actually this one here you're looking for, the one called Launch Wizard. Now, that's because the EC2 Launch Wizard that we used automatically creates a security group named after itself. So it's not the RDS Launch Wizard and it's not the default, it's the Launch Wizard. So select that option and click on Save. And now if we go back to our EC2 console, recall the command And this time, we're immediately into the MySQL prompt, which is fantastic. And I can do now the show databases command. And we have here 4 default schemas, which were created automatically. But more importantly, we have a 5th one, which is the bookstore database. So that's the schema that the RDS wizard automatically created. Of course, we could do use bookstore and we could do show tables, but we haven't created any, or if I can type that correctly, we haven't created any tables yet, so we are seeing an empty set. So that's giving me a really nice warm feeling. So leave this EC2 instance running in the background while we do the next few steps, because I suspect it's going to be useful to have a little peek and a poke in that database. Well, we're getting very close now. The only remaining job is to modify our WAR file to use the live database instead of using the hard-coded in-memory database. Now, the Spring configuration file that we've been working throughout this course is the file called application.xml. And of course, I must remember that many of you on this course won't be familiar with Spring. If that's the case, then just think of this application.xml as being the global configuration of the system. And these 2 lines here are telling Spring that we want to use 2 classes in our system. In particular, this one here, the book service, is a mock implementation containing hard-coded in-memory data. And I wrote that years ago now for the Spring MVC course, I think. You'll find that under the services package, and there it is, book service mock implementation. And you can see at a glance that we're creating a great big long list of hard-coded books. We don't want to use that anymore. And I've created for you an alternative version of this file called application-db.xml. Now, this is a direct drop-in replacement for the application.xml file. The key difference would be, I'll highlight down at the bottom here, for that book service, we're using a production implementation instead. And to cut the long story short, that is going to use a real-life in-memory database. The database operations are going to be performed by this object here called the book DAO, and it has an init method, which means at startup it will automatically run this function here, which is going to create some tables for us, which is very useful. So whether you know Spring or not, I hope that feels reasonably understandable. I think it would be worth looking at this book DAO cleaner JDBC impl. You'll find it in the data package, and there it is right there. And again, I won't go into great detail here, except to point out we have some inserts, we have some creates, we have some selects, and so on. Definitely all database operations inside there. There's really just 2 jobs to do to make this live. The first thing we'll need to do is rename it. If we rename this to application.xml, then it will be picked up by the Spring app. So step 1, we'll refactor rename the old application.xml to application-nodb. Doesn't really matter what you call it. And then the new one we'll rename to application.xml. So that's great. That should be now picked up. But the big job, the important job, is we need to configure this data source here. The data source contains the URL of the database, the username, and the password. Oh, there's also a driver class name here, which, as you probably know in Java, is always going to be supplied by your database vendor. I've taken the liberty of already giving you this database driver, com MySQL JDBC driver. If you're working on your own application here that you're retrofitting, and you're not working with my code, then you will need to make sure in your lib directory, you have the MySQL-connector-java jar file. Any recent version of it will do. If you don't have that, then you can very easily download that from the MySQL website. So obviously we need to put in the correct URL here. Well, as you know now, you'll find that on the RDS page, on your instance list, select your instance, and we have the endpoint right there. So we'll copy that string in, which of course will be different for you. Now you're not going to need the port number again, so we'll delete that. So that URL is not quite right yet. The front of the URL will be jdbc:// the standard form for a JDBC URL. For the username and password, temporarily we will use the VPP admin and whichever password you used for VPP admin. Now, this isn't a good thing. The VPP admin has kind of full access to the entire database, including being able to create and drop tables. Now for security, we really should create a new user on that database with limited privileges and use that for our application. But at least to get this application started, we are going to need to create the table. So I'll run with that at first. And I think in the next chapter, where we're going to tidy everything up, I will return to that and create a less privileged user. All we need to do now is run the build scripts. To rebuild that WAR file. Before we deploy it, however, I don't know if you know this, but this project actually has a class called springclient.java. And the idea behind this springclient.java file, I guess we used this while we were developing the app before we built the web pages. It's a little test harness that opens that application.xml file and does a few basic operations on the system. So I can see here that there's a function there to list the entire catalog of books, and then they're searching for a particular book and then doing a few other things. And there's 2 lines here which are commented out which create a couple of books. I guess we've commented that out because the second and third time you run this, you don't want to recreate those books. So what we could do before we do a deployment is we could check if this standalone client works and is calling our remote database. And it certainly should do. Remember, the firewalls included our local desktop IP address. So let's just dive in and we'll run this as a Java application. Well, we have an exception, but I have a feeling this is a really good exception. Bottom of the stack trace here is an SQL exception. Apparently, there was no database selected. And I think that's really good because I think that's proving that we are contacting that remote database. The problem's a very simple one. I just forgot, really. Here in the database URL, we also need to specify on the end of the URL the schema that we're talking to, which for us was called bookstore. So let's try that again. The code's now running. I think all that's happening, though, is there are no books in that database, so it's showing us nothing for the catalog. And when it's searching for a book, it's not finding any. And of course, we can easily fix that by removing the comments on line 20 and 21. Let's try that again. And we are now seeing data coming back. So if you go back to your EC2 instance now, I'm assuming that's still running for you and you're in the MySQL prompt, we can now do a show tables, and that's good. We can see the book table. And be careful here if you're doing a select. If we do a select all from book, this is case sensitive on this engine and this flavor of Linux. So you will need all of that in capital letters. And that's great. So we didn't have to do any of that. I think it's a really good thing to do that before we start deploying the WAR file, just so that all of the niggly problems are fixed before we introduce the complexity of a WAR file. Now, I think I built the WAR file a little earlier, but just to be absolutely sure, I'll run that build again. Well, a minor problem is that because I restarted my EC2 instance, and you might have done the same, the IP address of your running instance, as I mentioned before, will have changed. So if you made a bookmark or something in the previous chapter, then you will need to update that bookmark. The IP address will be different. So again, we're going to :8080, and I think we're going to get a connection refused. And that's because this is another problem that we'll be solving on the next chapter. At the moment, when you restart a server, the Tomcat instance will not automatically restart. So back in your console, we'll now exit MySQL, and we need to do a sudo service tomcat start. I'm sorry, that's Tomcat 8 start. That might take a short while to start up, but eventually you should be able... Yeah, we're now getting back to the Tomcat welcome page, and we should be able to go into the Manager app. I've already forgotten what the username and password for the Manager app is. I know we set it in the previous chapter, but I can check that by going into usr/share/tomcat8, and then there's the conf directory, and I think we were using the nano editor for the Tomcat users.xml file. And well, I'll need to control X because I should have used sudo there. So yeah, on the video, I used the username of admin and the password of admin. And remember, I'm only doing that because I know as soon as I finish recording this video, I'm going to be trashing this instance. So I don't really care about security here, but you probably do. Get yourself a strong password there. So it's admin, and for me, admin. So there's our bookstore that we deployed earlier, and I think for safety, I'm going to undeploy it. So just find the button undeploy on the same row as bookstore. And that's saying OK, and just check bookstore's no longer appearing in the table. And then it's this option here. We click on choose file, then navigate to your workspace, into your project, into dist, and find your new WAR file. As before, click on deploy. That's going to take a while to upload. So once the upload is complete, I hope you're getting the same message as I am, which is a rather uninspiring OK. All that remains then is to test the application as before. You can follow the link here to /bookstore, but because I haven't bothered setting up a welcome page, we will need to manually go to view all books.do. And we should see 2 books in our bookstore, and they're the exact ones that we just set up through the Eclipse application. So definitely a cause for celebration here that we're now reading and writing to a live database running on its own server. And remember, we also have luxuries such as automatic backups. The system we have at the moment isn't perfect. For example, we're still running on port 8080, which is not professional. We don't have a domain name here. And at present, if we shut down the server and start up again, Tomcat isn't running automatically. If you want to, you might want to close down your EC2 instance, as we did at the end of the previous chapter. Now, the main reason I'm doing that is just so that you don't leave the server running and then you forget about this course and you leave it running for more than a year, and then you lose your free tier. Remember, you only have that for a year, and then you start running up some charges. Now, there won't be big charges, but I don't want you blaming me for that. However, if we go to the RDS service, you'll find that RDS works a little differently. If we go into the instances here, there's no option. If I select that instance and go to actions, there's no obvious action to shut down this RDS server. In fact, what you can do is you can reboot it, but you can only apparently delete it. Now, that might seem a little bit drastic, but when you delete the instance, it will take a backup, and you can always use that backup in starting up a brand new database instance. So that's how you shut the server down and then start it up later. Now, I think that's a little bit tedious right in the middle of the course, so I'm going to leave my instance running, and as long as I go to the next chapter within the space of a year, I should be okay. So be careful yourself. If you're finished with the course now and you're not going to do the next chapter, then definitely delete that instance and shut down your EC2 instance. But if not, you can safely go to the next chapter where we'll do that tidying up of our server, just get a little bit more professional. I'll see you then.